Greetings, everyone. So I want you to prepare for the next quiz, and that will be on reduction of order. So not a quiz on variation of parameters, but on this one. Okay, and I want you therefore to use this method. Now, this is the question, but one information that you do need here is that homogeneous solution. So why homogeneous? So a solution, or at least for the complementary, homogeneous one is x plus 1 times ex. Okay, looks a little bit more daunting, but okay, you guys are now big boys and girls, right? So you can handle this. Okay, so step 1. What do we need to do? Well, we know that in such a situation, we're going to use this homogeneous solution that we have to do a variation of parameters. Okay, so this is the guy that we're going to work with. So let's box this, because these are the guys that I'm going to have to come back. So each time I introduce a new variable, know where you do that you can go back, plug it in, right? Okay, so what do we need? We need a derivative. Y prime is u prime x plus 1 ex plus, now, okay, there are 3 terms, so we have to do each of these terms. The derivative of x plus 1 is just 1, and then we have u x plus 1 ex. And then y double prime, that's probably even longer, so let me give myself a bit more space. So derivative of the first, that would be double prime, right? X plus 1 ex. Now, derivative of the second is ex. Derivative of the third, okay, that's taking care of this one. Now that one, it's a bit quicker. That's u prime ex plus u ex. And then the last one, derivative of the first is u prime x1 plus ex plus u ex plus u x plus 1 ex. All right, and now we have to plug this in. It's, as I said, it's a little bit more work, but you have a whole day for these kind of things, right? So what better to spend your day on than calculating like this long algebraic formulas, okay? I'm going to just copy everything, and then later we will gather whatever we can gather. Well, okay. I see here it's a 2, so I'm going to make myself a little bit, not double copying everything. In fact, I see here another one. So again, I'm not going to double copy this one. And actually I see here another one. So this is a 2 here. And we have seen this, right? This happens, right, all the time. 2u ex, well, that one perhaps is a little bit more surprising. And then plus u x plus 1 ex. Right? Yes. Okay. That's there. Then minus 2x plus 1 y prime. That is u prime x plus 1 ex plus u ex plus u x plus 1 ex. I guess I could have combined some here. And then minus x squared plus 2x minus 1 u, no parentheses, no needed, u x plus 1 ex. Good. And there seems to be an ex everywhere, so I can multiply. And this should be then equal to x plus 1 cube ex. Now, let's try to be a little bit smarter here and minimize it slightly. I don't have to do that, but I know that there's an ex in every term, even in the right-hand side. That was so nice of them. So I'm going to cancel those ex's, because they, right? If I divide every single term by ex, then I'm allowed to do that. Okay. There's also this x plus 1. What's the highest power seems to be x plus 1. This is a bit annoying here that we have this u here. So we only have this power x plus 1. So at least one power can go. Okay, so this would simplify this. This would get rid of this one, and this would get rid of the guy here. And then, of course, here it would be 2. All right, just to have a little bit less to write, but of course it gets messier because now you have things are gone, right? So, okay, u double prime. There is only one coefficient left. Well, be careful because an x plus 1 or an x plus, so let me underline them. X plus 1 times x plus 1, so this is x plus 1 squared. Good. What else we have? Then the u primes. All right, so that's the green one. So here we have a 2u prime. So the only thing that I'm looking at is the 2 together with the x plus 1 here, right? So there's 2x plus 1. There's a 1 here that is plus 2x plus 1 squared, because there's this, don't forget that x plus 1 outside here, right? And that's a u, that's a u. Here's another guy, and that is minus 2x plus 1. That's it. Okay. And then plus u. Now, if everything works fine, this should be 0, right? So, oh, blue, I use blue. Let's do orange. Okay. So, plus u, and do it in orange then. Where are my u's? There's one here with the x plus 1. Don't forget that here. So, there's a 2x plus 1. There's a guy here, so it is plus ux plus 1. No u. Don't write a u because you have already factors out. So, x plus 1 squared. All right. Then there's this guy, which is just with the minus 2. And then there's this guy that is, no, I keep writing the u. Don't write the u. It's just minus 2. Right? And then there's this guy, so minus 2x minus 2, I guess, I distribute. And then finally, there is this guy here that is minus x squared minus 2x plus 1. Right? So the minus sign I distribute here, and there's nothing left here. Okay. Well, this is the crucial one. So let's see that this is correct. So there's 2x plus 2 plus x squared plus 2x plus 1 minus 2 minus 2x minus 2 minus x squared minus 2x plus 1. The breadth and x squared minus x squared, that's already good. 2x minus 2x, what else? Another 2x with a minus 2x starts looking good. 2 minus 2, I like it. And then 1 plus 1 minus 2. This is very promising, right? It's now quite unlikely that I made a mistake, because the chances that this still cancels out is much less that this happens. Of course, I could make a mistake that I started from the wrong equation, but that's a different thing. Which, by the way, I won't penalize you much if you do that. As long as everything else is correct, that's fine. But very often, if you start from the wrong equation, you might end up with something impossible to solve. But okay, so where are we? Okay, so let's gather what we have. We have, we have u double prime x plus 1 squared plus u prime. I should also perhaps work this out now, right? 2x plus, oh no, the 2x's and the minus 2x cancel, so that's even easier. So then there's a 2x plus 1, yeah, let me write this in black. So, so these two cancelled, right? So there's only that one left, so that is a 2x plus 1 squared. And that is equal to, well, we have this side here, which was an x plus 1 squared, right? Don't forget the square here, x plus 1 squared. Now, look how nice. X plus 1 squares, they all go. We couldn't do it right away, so there's one left here, okay? So, oh, that becomes very nice, right? Now, u double prime plus 2u prime equals 1. That's nice, right? Because, well, first of all, it's a second order, but, so this is part of step 2, of course, right? This is really where step 2 starts, right? I'm now saying, well, v is going to be a new parameter, or a new function, namely the derivative of u. So, box it again, because I'm going to come back to this. So the equation now becomes v prime plus 2v equals 1. Okay, so step 3, I have to look at the complementary homogeneous equation, so that is v prime equals minus 2v. Well, okay, you want me to, I'll write it one more step, but it will less. So v prime plus 2v equals 0, so that means v prime equals minus 2v, and if you then bring everything to the right side, to get dv over v equals minus 2 dx, sorry, let's use the right variable. So if I antiderive, I get ln of v is equal to minus 2x plus a constant. Let's think about it. What are we doing? Yes, now we are looking for the general solution, right? We have, oh no, we're not, sorry, we're still in the homogeneous one, so we need one solution only in this case. I know it's very confusing. One do we want one do we want all of them? Okay, so this is fine. I don't need a constant here, and so then I see that v taking the exponentials, right? So then I get v is e to the minus 2x. Great. What next? Well, once we know this, we're gonna do. So this is step 4 to get now a particular solution. This is the homogeneous solution, so we know that will be a new parameter, w, and then this homogeneous solution that we found. So again, I'm going to box this because I introduced a new variable, namely w. A variable or function or parameter, whatever you call it. Right, what do I need is v prime, that is w prime e to the minus 2x minus w e to the minus 2x, and that's minus 2 I meant to say, right? If I plug this into my equation, in which one? Well, we should also keep track of the equations, right? So I'll put those in red. So this is the one that I'm now going to use. So I plug in there, that is w prime e to the minus 2x minus 2w e to the minus 2x plus 2 times v, which is w e to the minus 2x, and that is equal to 1. Great. What needs to happen happens, namely that these two cancel, because this should be only depending on w prime now. W prime is, and bring this to the other side, it comes with a plus sign. Okay, what is the next step? Well, this one we can solve by anti-deriving. So this becomes e to x over 2. What about the constants? Yeah, now I'm interested in the constants, because I'm going to work out the general solution now. So I keep the constant here. Right, as I said, this is only part, this is not original y. So now everything goes, we're trying to get back to the original y. What is this one? Well, this we get from here, right? So we see that v is equal to e to x over 2 plus c times e to the minus 2x. So this would be actually half plus c e to x. Oh, don't say, oh, come, I'm going to rename this constant and make it 1. No, you cannot do that, right? This is not a constant, this is the constant. There's no need to rename it, so I'm going to keep it for now. Okay, what now? Well, since I have my v, I have to go back. Where did v come from? Well, v came from here, right? From u prime. So u prime is equal to a half plus c e to the 2x. That means that u is the antiderivative of this. Okay, let me write it up one more time. So this means that it is a half x plus c e to x divided by 2 plus. Do I need a constant? Yes. So I'm going to put a constant here and let's call it b. I'm almost done, right? Because this is u, and what is u? Where does u come from? Well, u comes from here. So I have to just multiply this with x plus 1 e to the x. So y is x plus 1 e to the x times whatever I have here, a half x. Now this c over 2 I'm going to call a. Oops. Don't have to, but just makes it easier because there's an initial condition problem. So I do want to have as simple as possible system of equations with not too many fractions and so on. Okay, so this is my general solution. This is the general solution of my equation. So what they say is if x is 0, then y was 1 and y prime was negative 1. If my memory is still okay. Yep. Okay. By the way, here, why can we plug in x equals 0, you might ask. We always were avoiding that. Yeah, but this time it's an x plus 1 here. So what we should plug in is minus 1. But everything else we can plug, any other initial condition will work. Okay. So plugging these two in, we get 1 equals... okay, this becomes 1, and this is also 1. So then we have a half, that's also 1, plus e to the 0, that's nothing. And b plus b, right? Yep. And so we see that a half is equal to a plus b. Now we need the derivative, so y prime. Okay, so the several terms, right? So we have to do derivative first, that is 1, and then copy the rest. Plus we copy the first, take derivative of the second, which seems that nothing is happening, but that is just because it's an e exponential. Okay, and now this finally we copy the first 2 And then we take derivative of the second, that is a half plus 2a e to x. You know where the 2 comes from, right? And the b is gone. Yup, and that is equal to -1. Okay, so if I plug it in, this is -1 is equal to now. We're plugging in 0. So what we left in this part is a plus b. I hope that is clear. In this part, there is left 1 times a plus b, right? The 1 here, and then the a plus b. And in this part, we get left 1 times a half plus 2a. Okay, so what we have an a plus a plus a 2a, so 4a. We have a b plus a b plus 2b, and then we have a half here, and that becomes, if I bring that to the other side, it becomes -3 halves. So that's one equation, and the other one, I'll write it underneath here, was a plus b, right? Okay. So again, we have a bit of choices here how we do it. We can solve for a. Let's do the substitution once, because I don't know how many times I showed it. So I solve for a. So that means that a is a half minus b, and I plug that in here. So we got -3 halves plus 4 times, no, -3 halves equals, let me write, -3 half, I'm plugging it in the top one here, in this one, right? Is 4 times a half minus b plus 2b, that is 2 minus 4b plus 2b, that is 2 minus 2b, and that is -3 halves. So bring the 2b there and the plus 3 halves there, that is bottom 7 halves, and that is 2b, so b is 7/4. And then once I have that, I can plug this in here. So a is a half, which is 2/4, minus 7/4, which is 5/4. Okay, and so our solution is x plus 1. Where is it? X, yeah, here. Hey guys, I was wondering here. I plugged in right wrong here. Here x equals 0. There's no half here. I was thinking, why do I have this half here? Okay, there's no half. Forget it. It's just 1 here. That makes it this easier. And did I have the here? I think I plugged it in correctly, right? Yeah. So okay. So this is slightly off. Let me erase this here. So let me double check now, right? I take derivative. No, I plug in 0. This is 1. This is 0. Also 1. And this is I plug in 0. Keep thinking that I'm plugging in 1. No, this is a 0 a plus b. Okay, so now it's correct. And here, right? There are 2 terms where there's an x here. It's only here because I took derivative. There will be no x, so that half does survive. Okay. Okay. So 1 equals a plus b. So now I did substitution the previous one, so I'm now lazy. I'm going to multiply this with -4 and add up there. So then I get -3 halves minus 4 equals -4a plus 4a, that's 0, plus -4b plus 2b, that is -2b. Okay, so this is -8, that is -11 over 2 is -2b. So I see that b is 11/4. And then since a is 1 minus b, right, that is 1 minus 11/4, that is minus 7/4. Okay, it didn't get simpler. Let me double check here. I thought the solution had no square in there, but I just did it very quickly, so I'm not so sure. 5, I had to write it down. Where did I write this down? Here. Yeah, I think it's correct. No. Sorry. Oh, I see, I see, I see, I see, I see. Yeah, one thing I could have done and probably would have made my life easier is to distribute this EX out. And I am kind of surprised that there's an EX here. Yeah, that is correct. And did I lose this minus here? No, a minus. That's a minus there. I have here, yeah. Wait, did I write my V? Yeah. Oh, here, see, I knew there's a minus somewhere missing. Here did I go wrong? Oh, I'm so sorry, guys. So there's a minus there. And of course, now this changes things a little bit, right? So this is a minus here. This is a minus. That means that this will be a minus also, right? Right? This will be a minus. So that actually, oh, but that doesn't make a difference, right? Oh no, but no, the issue is not that that's a minus. The issue is that this is a minus, right? So this is a minus. Okay, I'm sorry about that. This is minus c over 2, but I can replace that by a. That's not a problem. Okay, so it's on the very, very end that I made a silly mistake here. So the derivative, I have to be a little bit careful now because we have this minus here. So when did I take derivative? It's only the last one I take derivative. So this would be a minus here. Okay, so this would be, the only thing that changes is the minus here. Okay, so what was that? Oh, okay, there's a plus a minus 2a. So that cancelled and I get 2, so that was easy. So this actually cancels then. So this is all of that is 0. So that means that, sorry, let me erase now what is correct and what I still have to do. And since this is, I would probably have been better for me to multiply it out, because then I have a less, well, I don't know. So okay, let's. I did it now. There's the only thing that is a minus that I now could take off. So I'm just saying, sorry. The a terms, there's an a here, there's an a here, the minus 2a. That's why it's gone. So we have only a b plus b, and then also this half. Right, that is already brought to the other side here, but the 2 fell off. Okay, and yes, okay. So we see that b is minus 3/4, and then a, what is a then? A is, what was, a was 1 minus b, right? 1 minus b, so that is 1 plus 3/4, that's 7/4. So I find that the solution is y equals x plus 1 times ex, and then a half x plus a, which was 7/4 e to the minus 2x, plus b, which was minus 3/4. Let me get this out of the way. Minus 3/4. And that is the solution. And now I want to double check, and I'm pretty sure that is okay. That would be, okay, minus minus is a 3 there, okay. Yep, this is correct now. Okay, sorry for that. You see, it's so easy to get somewhere, it's something wrong, right? Now, this was not major. And if you do this, you would lose half a point, or perhaps a point. Depends a little bit on how serious the mistake is. But this, of course, it could also be the difference between win or lose. That one minus sign, if that's the wrong, goes the wrong way, then all of a sudden you have something that it's very hard to integrate, or probably even impossible to integrate. So it can get tricky. Also, I should tell you that there are many ways of writing this equation. Although this is one way, some people would factor out the 4, some people would bring in the ex, some even would expand the x plus 1. So it is really a little bit up to you how to write these things. okay? And these are equivalent forms. I do not want you, there's no one in particular that I'm insisting on. Whatever you write, whatever way you expand or not expand it, that's fine. But of course, you have to get to the end, right? That in the middle, we have to do the cancellation expansions. Yeah, make sure that you cancel whenever you can cancel, because you don't want to keep carrying around terms that are not they are actually zero, but you forgot to cancel them, okay? All right, right. So again, it's what can I say here is you have to be very, 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 very careful. And okay, when you do a quiz, I'm doing this now once, right? But I'm going over it the second time to see whether I make mistakes. But if you do this, you have the whole day time, so take your time, double check your calculations. All right. Oh, sorry.